In this video, we will discuss how formula for Euler's function can be derived from the multiplicativity of Euler's function. Not so long ago, we derived the multiplicativity from the formula. Please do not be concerned about this logical circle, because we have independent proofs both for multiplicativity of Euler's function and for the formula for Euler's function. So now we simply study the connection between these two properties of Euler's function. Well, first, let's calculate the value of Euler's function for a power of a prime number. Well, p is a prime number and alpha is some non-negative power. We can consider it positive, but it should also work for alpha equal to 0. But let's consider alpha to be a positive. So what is Euler's function? It is the number of positive integers from 1 to p to the power of alpha, which are co-prime with p to the power of alpha. But being co-prime with p to the power of alpha is equivalent to simply not being divisible by p. So we need to remove those positive integers from 1 to p to the power of alpha, which are divisible by p. And we understand that there are exactly p to the power of alpha divided by p such integers. So we simply subtract p to the power of alpha over p from p to the power of alpha, and this way we remove all positive integers that are not mutually prime with p to the power of alpha. So we gain such a formula for Euler's function of a power of a prime number. Now, take the prime factorization of an arbitrary integer, positive integer n. We understand that all these primes are distinct, they're pairwise distinct, which means that these factors are pairwise mutually prime. And now simply apply the multiplicativity of Euler's function and write that Euler's function of n is equal to the product of Euler's function of all these factors. And now simply use the formula for Euler's function of p to the power of alpha. And finally, notice that factors of the form p to the power of alpha, namely p1 to the power of alpha 1, p2 to the power of alpha 2, and so on, can be collected, joined together into n, of course, and all the brackets of the form 1 minus 1 over p just remain, and we gain the formula for Euler's function of n.